Today, I'm gonna show you how to solve LEETCODE question insertion sort list. It's a median question giving the head of a singly linked list. Sort the list use the algorithm called insertion sort. So the insertion sort algorithm is you basically insert sort iterates and consuming one input element each repetition and growing a sorted output list. At each iteration, insertion sort removes one element from the input data, find the right location where it belongs, and then insert it. And you can see it put the 3, compare between 6 and 5, and then put it in the 3. Like the 1, it compare with each number and insert. It's bigger, smaller than all of them. So put the 1 on the left side, and you can see the animation here. And then 8 is bigger and 7 is smaller, so I put the 7 before 8. And then when I wanted to insert the 2, I found it's bigger than 7, 6, and then bigger than 5, bigger than 3, and only smaller than 3, and a 1 bigger than 1. So I put it in this position. So I'm going to repeat the same thing for the 4 when I try to insert 4. So for this issue, you want to think about it. You want to write the exact step as what they ask you to do. The idea is for a lot of linked list question is that it's best to put a dummy head. So it's really make the code really easier. So what I wanted to do is put a dummy head here, and I will put 2 pointer. One is I will call the S as last sorted, and I will put this as in the head position, and I'll put another pointer in the head on next position, which is the current pointer, and I will also put another pref pointer in the dummy head. So then let's go through this list to see how we can sort. So first, I'm gonna compare and take a look between the value between the last sorted value and the current value. Okay, the current is bigger than last sorted, right? So it's sorted. Once I find it sorted, what I wanted to do is I will move the current to its next and the last sorted to the next as well. And I'm going to repeat the same thing. Make sure they are also sorted. So it's 3 smaller than 5, 5 bigger than 3, right? It is. So I'm going to continue to move these pointer. And then I moved 5 to 6. Is it bigger? Yeah, it's bigger. So I'm going to continue to move. So when this happens, when I move the current to 2 and the last sorted to 6, is 2 bigger than 6? No. So when this happens, the idea is that I'm gonna have to stop it here, and I will try to insert 2. When I insert 2, I have to go back to compare each value, right? This is where the previous pointer, the pref, will come into play. So what I'm gonna do is I'm gonna compare pref.next.vol with this smaller current value here. So the pref.next is actually 1, right? The value is 1. Is 1 smaller than 2? Yes. So I wanted to insert the 2 right after 1, but before 3, right? So then once I find this position right after 1, I will insert that, and after I finish the insert, I will move the pointer, and after that, after I inserted, I will move the current to the last sorted, the next value. So the S and C gonna continue to move to the next one after I inserted a 2. So let me show you how to do this in code. So first we want to rule out a few edge cases. If not had, like if it's an empty list, then we simply don't need to sort anything, or not head dot next, or there's only one value, then we also don't need to insert anything, right? So in these two cases, we will return head. So let me just making sure that the indentation is correct. Okay, all right. So then I'm gonna put the dummy head and list node. I'll create a list node for the dummy head, and I will set the next dummy heads you can see here, and the list nodes here, volt and next, right? I'll set the next to head, and then so if you look at here, the node vol is between these two values. So this time I'm gonna set the vol to minus 5,000. The reason I'm doing this is because if I set it to a no value, it will not allow me to compare the pref.next value. So I just put the value here, and I will call, so the S is last sorted, and I'll put it in the head position, and then I'll put the current to the next head.next position. Once I do that, so if while curl happens, right? So if the last sorted double, so at this time we are just comparing these values. Say, let me move these here. Let's say if last sorted double is smaller and or equals to current double, right? So the last sorted is equals to last sorted dot next. So I'm just gonna move the pointer and the current equal current dot next. The else situation, in the else situation, I will set the pref to the dummy head, and then while the pref.next double, so after this I have already moved the last sorted to 6 and the current pointer to 2, and while the pref.next double, which is 1, is smaller or equal to current double, I'm gonna continue to shift the pref to pref.next until it's no longer small or equal. If it's bigger than if like 3 is bigger than 2, I won't shift. That means I already find the right position to insert, which is between 1 and 3. So next, what I'm gonna do is I'm gonna try to insert. So the last sorted dot next. So the last sorted dot next is equals to current dot next, which will be the 8, right? And the current dot next equals to pref dot next. So the current dot next, I'm gonna have to put it to the pref dot next to insert this value. Pref dot next equals to current. Pref dot next equals to current. It will point to the current value, and the current is equals to last sorted dot next. So then I continue to move the pointer while this condition is true. After I go through the entire list is sorted, and then what I'm gonna do is return the dummy.next. Yep, and you can see the output is expected and it's faster. Let me know if you think the video is helpful. Please like the video and subscribe to the channel, and I'll share more LeetCode questions soon. And I'll see you soon. Bye bye.